Hi, in this video we are going to discuss about Euclid's division algorithm. Euclid's division algorithm is based on the concept of Euclid's division lemma. So first we'll revise Euclid's division lemma and then we'll see what exactly Euclid's division algorithm is. Now let's take one example where we want to divide the number 30 by 18. Now if we carry out a simple division, what we'll get? 30 divided by 18, so 18 ones are 18, and if we subtract 18 from 30 we get 12. Now in this case we call 30 as dividend, so these are the basic terms. Then 12 is remainder, 18 is our divisor, and 1 is quotient. So all you are familiar with these terminologies. Now you can see that the dividend 30 is equal to 18 into 1 plus 12. That means dividend is equal to the divisor into quotient. In this case the quotient is 1, so 18 into 1 is 18 plus remainder which is 12. That gives us the final value as 30. Now in the actual value form this can be represented as 30 is equal to the divisor 18 into quotient 1 plus remainder which is 12. Now this equation is nothing but the Euclid's lemma form. Now any division like 30 by 18 can be represented in this format, and this is called as Euclid's division lemma form. Let us extend the concept of Euclid's division lemma to find out a shape of two numbers. We'll take the same example that we already took. So we want to find out a shape of 18 and 30. Okay. Now in the first step what we have to do, we have to find out the bigger number. So as 30 is greater than 18, the bigger number will become our dividend. So as 30 is the bigger number, the dividend will be 30 and the divisor will be 18. Now let's carry out this actual division. So if we divide 30 by 18, we'll get 18 ones are 18, and if we subtract 18 from 30 we'll get 12. Now this division can be represented in Euclid's division lemma form. 30 which is dividend is equal to the divisor which is 18 into quotient which is 1 plus the remainder 12. What we did in the first step, we found out the bigger number, so the bigger number became our dividend and the smaller number became our divisor, and we wrote down the division in the Euclid's division lemma form. Now in the second step we have to check whether the remainder of the previous step is 0 or not. As the remainder is not 0, we have to carry out this procedure again. So as remainder in previous step is not 0, the remainder of previous step will become our new divisor, and the divisor of previous step will become our new dividend. So in this case the new dividend will be, this is very important, so the remainder of the previous step will be our new divisor and the divisor of previous step will be our new dividend. So 18 will be new dividend and the new divisor will be remainder of previous step, which is 12. Now we have to carry out this division again. So similar to first step, in this step if we divide 18 by 12, what we get? 12 ones are 12, and if we subtract 12 from 18, we get the remainder as 6. So this division can be represented in Euclid's division lemma form as the dividend, which is 18 in this step, so 18 equal to the divisor, which is 12, okay, and multiplied by quotient, which is 1, plus the remainder, which is 6. Okay, now again you can see in this step the remainder is not 0. So as remainder is not 0, remainder, which is 6 in previous step, is not 0. What we have to do? We have to take the remainder of previous step as our new divisor, and the divisor of previous step, the divisor of the previous step will be our new dividend. So 6 2s are 12, and if we subtract 12 from 12, we'll get 0 as the remainder. So we can write down this division in the Euclid's division lemma form as the dividend, which is 12, equal to divisor. In this case the divisor is 6 into the quotient 2 plus remainder as 0. Now after step 3 we got the remainder as 0. So one can clearly see that at the end of this step we are having remainder as 0. So we have to stop at this point, and the divisor at this stage becomes our SCF. So in the step 4, as remainder in previous step, remainder in the previous step is 0, the divisor will be SCF. So what is the divisor in the step 3? The divisor is 6. So SCF of 18 and 30 is 6. So let's revise again all these points. So let's revise again. Now we are having problem where we want to find out SCF of 18 and 30. In the first step we found out the bigger number. So what is the bigger number? So the bigger number is 30. So we took 30 as our dividend and 18 as divisor, and we carried out the division. Now at the end of this division we got the remainder as 12. As the remainder is not 0, we followed this process again, where the divisor became our new dividend, which is 18, and the remainder at this stage, which was 12, was our new divisor. Now at the end of this division we still have remainder as 6. As the remainder is not 0, the remainder of previous step became our new divisor, and the divisor of the previous step became our new dividend. So we carried out this division again, and at the end of this division we got the remainder as 0. So at this position we stop. The divisor at this stage is the SCF of the two numbers. So with this we can easily find out the SCF of two numbers. We have to repeat this process till the remainder becomes 0, and at the point where the remainder becomes 0, that time the divisor of that step is the SCF of two numbers. In the earlier example, we found out SCF of two numbers. Now what if there are more than two numbers? So let's extend previous example and find out SCF of 18, 30 and 45. Now in this case, the first step is to find out SCF of two numbers. So we'll take first pair as 18 and 30. So we'll first find out SCF of 18 and 30, which is obviously 6 that we found out in previous step. And in the next step, we have to take the next or remaining number. So we'll take SCF of 18 and 30 as our first parameter or first number, and the remaining number is 45. So we'll go for 45. Now in this case, again we have to find SCF of two numbers. So we'll apply Euclid's division lemma and we'll carry out actual division. So 45 we'll divide it by 6. 6 sevens are 42 and what remains is 3. So we can write it in Euclid's division lemma form. Applying Euclid's division lemma. So what we get? The dividend, which is 45, is equal to the divisor, which is 6, into the quotient 7 plus the remainders 3. Now as the remainder is not 0, this will become our new divisor, and divisor of previous step will become our new dividend. So in the third step, as remainder is not 0, we are having new dividend as 6 and the divisor as 3. So if we carry out actual division, so 3 2s are 6, and if we subtract 6 from 6, we get 0. Now again we can apply Euclid's division lemma. So applying Euclid's division lemma, what we get? The dividend, which is 6, is equal to the divisor 3 into quotient 2 plus the remainder 0. Now at this stage the remainder is 0. We have to stop over here, and the divisor at this stage, which is 3, is the SCF of 6 and 45. So SCF of 6 and 45 is 3, but this is nothing but SCF of 18, 30 and 45. So this way we can extend the concept of finding out SCF of two numbers to n number of numbers.